he chose for this project is a scene in Up where the main character's house is rigged with balloons and lifted from the ground, lifting the house into the air to fly away. The scene proceeds like the following. The main character, Carl Fredricksen, who's an older gentleman, is being forced into a retirement home. Carl does not want to leave his house in the memories of his departed wife, so he comes up with an idea. Being a balloon salesman, he rigs together tons of balloons on strings to the fireplace inside his home. The idea being here that he wishes to sail away in his floating house. The balloons are released from a giant holding bag behind his house into the air. The massive amount of balloons attached to his house lift the building off of its foundation and into the sky. While this was an amazing scene in the movie and a huge part of his journey, I have always been curious as to whether it was possible to lift a house like this with just balloons. I have now heard of people who tie themselves to balloons and are carried off floating, but a house would require much more. I do believe this to be possible, so what else to do but apply physics?
The way that we believe a calculation could be made is that a buoyant force applied by the helium balloons has to be able to apply a force great enough to lift the house off the ground. The calculation that needs to be made is for the force needed to lift the weight of the house. Some aspects of the house would have to be estimated, such as size and weight, but that can be done. We looked up some house moving companies who have lifted old structures to be moved someplace else to find an estimate for the weight of the house. The next step would be to determine the volume of helium needed to apply such a force. This can be done by using buoyant force equations. Then the last step would be to determine how many balloons would be needed to fill the volume needed to lift the house. Some things that would need to be neglected to make the problem simpler would be such factors as the force of friction between the house and the ground and the weight of the added strings to the balloons. Another factor that could be ignored in this problem is the temperature of the air and the atmospheric pressure at a particular place on Earth.
Carl Fredricksen's house would be around 100,000 pounds or 45,360 kilograms. So the force required to lift the house off the ground would be equal to F equals MA and is 45,360 times 9.81 meters per second squared. And that gives you 444,981.6 newtons. And that is the force required to overcome gravity. Then the balloons need to be added into the equation. The net force will be equal to the weight of the helium in the balloon. Net force equals the buoyancy force minus the weight, which equals the density of the air times the gravity times the volume of the object minus the density of the helium times the volume times the gravity. Gravity is equal to 9.8 meters per second squared. The density of the air is equal to 1.29 kilograms per meters cubed. Density of the helium is equal to 0.178 kilograms per meters cubed in normal conditions. When calculating it all out, the net force is equal to 10.9 newtons over meters cubed multiplied by the volume. So to apply 444,981.6 newtons of force, 40,822 meters cubed of helium would be needed. So the volume of a regular party-sized balloon is 4/3 pi radius cubed equals 0.5 cubic feet or 0.015 cubic meters per balloon. Then 40,822 cubic meters divided by 0.015 cubic meters would equal about 2,721,467 balloons.
In conclusion, it is possible for Mr. Fredricksen's house to be lifted up off the ground. So the whole premise of the movie is not entirely fictional. The amount of balloons needed to lift the house off the ground is concluded to be around the number 2,721,467 under normal conditions. While there are some limiting factors in this scene, like we have explained, it is interesting to find out that balloons have the ability to lift and carry things away. At this time, we are going to perform a small-scale demonstration.
If Carl Fredrickson's house is 100,000 pounds or 45,360 kilograms and it needs 2,721,467 balloons to lift it off the ground, then for our small-scale demo, we divided the mass of the house by the number of balloons needed to find out that with one helium balloon, we should be able to lift up 0.01667 kilograms of our demo house.
Go.
So using Play-Doh, we made a house which is 0.01667 kilograms, and using our blue helium balloon, we're going to see if this actually works. Well, it's off the ground.
It works! Okay, let it go. Okay, let it go.
I hope you've enjoyed our presentation on the movie Up and Carl Fredrickson's house being lifted by a balloon.